Hello,
Hi,
Nishit.
Shalom.
Hey, how are you?
I'm doing fine. How about you?
I'm good. I'm good.
Cool.
So yeah, let's start. I'll start with a brief introduction of mine.
Sure.
So yeah, my name is Solan. I kind of work with AB and Bev right now, leading the data engineering side with the generative AI capabilities. Yeah, mostly I work on Azure tech stack. And tech stacks, to be more in detail, I use Databricks, and for storage levels, we use ADLS and Delta tables. Yeah, that's about it. You can start with your introduction.
Yeah,
Give a
sure,
bit
Shalom.
about like the project that you are working on right now, and like what use case you are solving, and any challenges that you face on a daily basis.
Sure. So I'm Nishit Dua. I graduated from Guru Gobind Singh University, Delhi. Then I got an opportunity to work with Amazon as an intern. There I started working on data tools such as Airflow, and I also got to work on AWS and PySpark. After that, since July 2022, I've been working with Infosys. I have worked on two projects. Currently, I'm working with a client Walmart. There, my role is to like to build end-to-end pipelines using Scala Spark and also orchestrating all the jobs through Airflow. The cloud we are using is Google Cloud Platform. Basically the services in GCP we are using for storage is GCP BigQuery, and for data lake we are using GCS buckets.
Mhm.
And yeah, that's all for my introduction. So uh, for the difficulties which I faced in this project was it is a monthly load, so the pipeline will
Mhm.
be triggered every month. So earlier, what was the flow? Business used to upload files to the bucket, and then we have to check it manually and trigger the tag, which was capable for to validate the files for data quality. So to overcome this manual process, what I built was I created a simple tag for a file voucher. So it will be triggering it for the first of every month, and it would be triggered for let's say 10 days. And if uh, in any time between first to 10, when the file will be uploaded, then it will directly trigger the pre-validation load tag, which is using trigger tag operation.
Mhm.
Yeah.
So suppose someone uploads a file after the 10th of the month.
Then that would fail. Like we were given,
Okay.
it would be uploaded between 5 to 7, so we just kept a
Okay.
buffer of 3 days.
Okay. Got it. Got it. Okay. So, can you explain, like in brief, like take one business use case that you solved. I just want to get into a little bit more details about what was the use case that you solved for, and uh, how did you go about, approaching the D side, like the data engineering side. Yeah.
Okay, so as this project is new to me, so I'll share my previous project details.
Mm-hmm.
There we had to work on a pharmacy data. So there we had a transactional data, and we were using star schema. Like there was a fact table which was having millions of record, and it was also storing incremental data. And
Okay.
there was let's say there were 50 or 55 dimensions table which were linked to using the foreign key relationship. So what we faced is at start we were when we were joining in Spark code, we were facing some delay. Then we got to we can use as the size of dimension table was just in MBs, few MBs, 20, 30 MB, while the fact table size was approaching to 500, 600 GBs. So then we used broadcast joins for uh, this all the joins which we were doing on the fact table. So it
Mhm.
reduced our time from like I would say 10 times. It reduced the time, so that
Mhm.
helped a bit.
So yeah, so as you have already tapped into broadcast joins, so why do you think broadcast joins when you do a join between a smaller table and a larger table? Why
Yeah.
do you think broadcast join takes relatively lesser amount of time than a normal sort merge join?
Sure. So let's take an example. If we use normal join, so what would be like all the data is present in partitions. So both the tables would be present in the partitions, and like let's say if we want a join which will be happening from data from one first partition to the third partition, the shuffling would be happening. So the
Hmm.
shuffle operation makes like takes a lot of time. While in the case of broadcast join, if the size of a small table is comparatively low, that it could be stored in every node, then the shuffling operation would be not needed, and hence it would take a lesser amount of time.
Okay, just a quick feedback here. So basically, the broadcast table, the smaller table, is actually not present in each node. It's
We are
present
creating
in the
hash
driver.
table for that
Yeah, it's present in the driver table and it
driver
is
node.
casted to each and every
Yeah,
machines.
got it.
That's why it's faster and it reduces. It does not use shuffle. That's why it's faster.
Yeah.
Cool. Cool. So what are the other join types do you know that helps us joining like two or more tables?
One is shuffle merge, which is default. Also, we can use. Oh, sorry. One is sort merge, which is default, and there is shuffle hash join.
Hmm.
Uh, that we can use in the cases where the data is large but not large enough to not large enough to like it can be stored in partition. So there also like to some extent shuffling can be prevented.
Okay. Okay. Can you explain partition pruning to me?
Partitioning pruning. Yeah, like let's say we are having some data which is being partitioned over four. Let's say the partition number is four, and let's say we apply some narrow transformation. So let's say on a transformation we just need three partitions, so we can just prune the next part, the partition which is has been vacant. That
Hmm.
process is known as a partition pruning.
And how does this help? Like, how does this help over a normal? So suppose you have a data set which is partitioned on a country column, okay,
Sure.
and you have
Mhm.
several other countries, and you put a filter. So how does this help in reducing your reducing your time to get the result out and inherently optimizing your performance?
So first of all, it helps in memory management. And
Hmm.
when we filter our data on the partition column, so what is the first step? It will check all the partition indexes which are being created. So if we prune some partitions which are not in use, so the time would be saved there. Like let's say we are manually in the SQL query, we are manually checking on the 10 columns which are
Hmm.
like partitioned. So if we have pruned two or three columns, it will reduce our time.
Okay. Got it. So suppose there are 15 partitions. How many tasks would it create in the backend in Spark?
Uh, 16, one for the driver node and one for each partition.
Yes, cool. Do you know, can you explain a little bit about the principle of data locality?
I'm not aware of that.
Okay, so it's basically keeping the data, like not moving the data and sending the code to the data so that we don't have to move the data around. This is what happens in a distributed system. Like as we
Okay.
have multiple machines, we keep the
Mhm.
data there. And as shuffling you said is an expensive operation, we don't
Yes,
move the
yes.
we move the code to the data to the
Okay.
machines. The operation is performed, and this concept is known as principle of data locality. Okay,
Okay. Mhm.
got it. So, do you know about data storage levels? Do you know what is serialized? Can you tell me the difference between serialized data storage level and deserialized data storage level?
So, like in the case of when we need to persist a data frame, we can just give our storage levels, which can either be memory So if we pass memory only, so the cached data set would be only saved in the memory, while we can also use memory and disk, so that it would be divided into memory and disk. Like to reduce our memory storage, we can use memory only with serialization. So here we can save our memory, so as it would be stored as a RDD, which is serialized. But here, few like some time would be taken to deserialize that object. So it is kind of a trade-off. If you want to reduce a memory, we can just take some extra time to deserialize and serialize.
And which one of them takes more, like which one of them provides you more amount of compression?
Serialized.
Serialized. Okay. Do you know the different read and write modes that we have for a data frame reader and writer API?
We can in read mode we can choose format, and it would be like we can pass any format like CSV, JSON, text file.
No, not the file format. So the reading modes, like we have permissive. So in that grounds, I'm saying. So basically, writer modes, if I say, what
We
are the
can use append, overwrite.
Hmm.
Like if we have incremental data, so we can just append the data frame, so the incremental data is loaded into the target table. Like if we want to say overwrite it, so we can use it, the earlier data would be truncated and the new data would be loaded in the table.
Okay, so so suppose you're appending a data set. So you are doing an
Sure.
incremental load every day.
Yeah.
It's a refresh that is happening.
Hmm.
How do you ensure that the data that is coming along every day is not the same data that is already existing?
For that, we should also be reading that the target table, and we can perform an left anti-join on that data, and to fetch all the new records which are being present and that are not duplicated. Then the targeted data frame we can use append mode to write it to the data table.
So your left anti-join will be performed under like what scenario? Like what would be your column combination? Like do you check the left anti-join with the whole row as such? Or do you do like with a certain set of columns?
We can just pass the primary keys for the
Primary.
left anti-join.
Okay, okay. Can you talk a little bit about memory management in Spark?
I haven't worked on the configurational side of Spark.
Okay, no problem. So there are like few kinds of memories that allocates. Like you can go ahead with the like for Spark, there is a reserved memory that takes like out of 5 GB, it would take 300 MB to the reserved memory. After that, there is something called as overhead memory or the off heap memory. That would take around like the formulation would be either maximum of 10% of the executor memory that you have requested for, or it would be 348 MB. If that's not the maximum, the 10% is not the maximum. So it would be 348 MB. The rest of the memory that is left, it's divided into 60-40 ratio. So within the 60-40 ratio, 40 goes towards the operational levels and 60 is again divided into 50-50 in a ratio of 50-50, out of which 50% goes towards storage and 50% goes towards execution. Now, this 50-50% could, now there is a very thin line between these. Like, suppose you are caching a data frame or persisting a data frame and you need more than what 50% is there. So it would use up the execution memory in that case.
Okay.
And if you need a little bit more on the execution side, it would eat up something little bit more of the storage side.
Storage side.
This is how the memory is mapped inside when you request for
Got it.
request for a memory to the executor. No worries. Okay, let's move on to certain coding questions. I will share a link. Copy the table first that I've pasted on the chat.
Hmm.
Got it, right? So basically the table has, it's a monthly sales table. It has two columns, month and sales amount.
Okay.
Clear, right? So every
Yeah.
month sales amount, what you need to calculate out of it is, so I'm pasting the question. So yeah, you can first paste the question here. Yes. So you need to calculate the difference in sales amount between each of this month. So the current month and the previous month. Try
Okay.
writing this using a window function.
Sure.
Can you change the language to SQL on your Notepad++?
We want to calculate difference in sales amount between each month and the previous month. So for this, we can use lag and pass sales amount. We don't need to partition it, so just we can order by it on month column. I guess this would work.
Yes, for each month you sales amount minus previous sales month. Okay, works. Cool. Let's move on to the next question.
Sure.
So yeah, so this is basically, so every TikTok user sign up with their emails. So suppose any new user coming along is signing up with their email IDs, and then they are getting a text confirmation out of it. Now,
Okay.
particularly, every user email can be associated with more than one text confirmation. Suppose you get a OTP today and you did not actually confirm it, and again tomorrow you are coming along and giving another OTP. So
Oh,
your
got it.
multiple text confirmation can come.
Mhm.
And as an analyst, what you need to perform is you need to find the activation rate, like how many people are coming along, but how many people are confirming. What is
Okay.
the activation rate? Now, there are
Okay.
two assumptions to it, saying that an analyst that is interested in the activation rate in
Mhm.
the email table may not include all the user that could potentially be in the email table, in the text table. So like here, if you check the tables, like the examples, you see the email IDs, which is 125236433.
Yeah.
So out of here, 433 is not present in the text table, right? So this
Yeah.
is someone who has like registered with an email but not verified his email. Similarly, the other way around also might happen. Like suppose there is a random 463 email ID that is present in the, like a text ID that is present, like 6996 that is present in the text table. which is not exactly present in the email table.
But we do not have any column for text ID in email table, right?
No, I'm just telling you, like it could
Okay, okay.
happen. It's
Okay,
not there
got
in
it.
this example. I mean,
Hmm.
that is the assumption that is written. See, the
Okay,
analyst, if you read the first point on the assumption, the analyst is interested in the activation rate of the
activation, right?
specific user, which may not include all users that could potentially be found in the text table.
Okay,
And
vice
confirm
versa.
the sign up action that you see confirmed. So confirmed is the sign up action. That means the user has activated the account. Okay.
Okay,
Okay. Now what you need to find out is the confirmation rate. So suppose the 125, the email ID that you see 125, they
hmm,
have signed up on a specific date, which is the 6/14. So the June month, on the 14th of June,
yeah.
that person has signed up,
Hmm.
and then on 125 they have confirmed. But the 236, if you see, they have signed up on a specific date, but then on the first instance it was not confirmed, and in the second instance it was confirmed,
Okay.
right? So
Hmm.
236 and 125 are two email IDs that were confirmed. So out of these three entries that you see, you get the confirmation rate, like 67% of the users that are coming along are confirming.
Okay, okay, got it.
So the questions would be write a query to find the activation rate, round the percentage to two decimal places.
Sure. Okay. So the total user IDs are 7771 6950 1052. Out of these three, two confirmed, which were having email ID 125 and 236.
Yeah.
Okay. So first we can just filter out a confirmed action in text table.
Hmm. Okay.
So we'll get these two records.
Okay.
Five, six. So we can now select the can also store this result in a CT. Name it. So
Okay,
at
so
this step,
join table that has all the filtered records as confirmed, and you have joined the tables on email ID, picking up user ID, email ID, and text ID. Okay.
yeah. So at this step, we'll be getting output as text ID would be 6878 120. Sorry, we are having user ID 7771, having email ID as 125. Text ID we have as 6878. The next 6950. ID is 236. Text ID as 236 6994 0. So at this point, we get this output. And
Okay.
then we can see it. Text ID. Or do we want percentage or what was the output? No. Okay, that this will look. Count star. So here count star would be 3 and count text ID would be 2. So it would be returning us 0.66. We can also round it to 2 decimal places. I guess this would work.
Yeah, this would work. Perfect. But I think the count, when you do a divide, you can do a count by distinct email ID. Why? Because a count star there, if at all a email ID is repeating in future, so that would count star all the email IDs, even if a duplicate email is present.
So can a different email ID be present, or
yeah, it
okay,
can.
then we can. Okay.
So suppose someone is trying, so you must have also faced this, right? When you go to sign up, sometimes you do use the same email ID again, and then it basically tells you have already used this email ID.
Yeah.
So that also gets registered, but then no confirmation comes out of that because you never use it again.
Okay, got it.
So it would be a distinct email ID here. No, it's completely correct. Okay, great. Okay. You are comfortable with normal Python, right?
Yeah.
Okay. Let's do this question. So straightforward, simple question. I'm pasting it on chat. Can you see?
Yeah.
So there is just an assumption here, not an assumption, basically a constraint here. You can copy the constraint also. Yes. So simply you have a list of elements here, 0, 1, 0, 3, 12. Okay. now what we need to do is write a function, like define a Python function that would take in this list, and it pushes the zero elements to the right side and pushes all the non-zero elements to the left side. But then you don't change the relative order of the non-zero elements. Basically, you don't sort it, because
Mhm.
if you sort it, this kind of problem solves itself, right?
Yeah.
But you don't have to sort it, but you have to move the non-zero elements to the left
Right.
side and the zero element to the right side.
Okay. Got it.
And
Uh,
the constraint is you don't use any extra space or any extra data structures for that sense. Like you have to do this in place in that one same data structure.
okay. Got it. So we can solve this with two-pointer approach.
Hmm.
Let's say choose I with 0, j with of j. If a of I is equal to 0, then j. So here in the first step, as a of I is not 0, so we'll be incrementing I with 1.
Hmm.
The j is j is also not 0, so j will be here only.
Hmm.
Okay. Oh, if it is not 0, then it would be. So I would be here only, j will also be here. And if a of I equal to 0, j is not equal to 0, we'll be replacing in this case, it would be replaced. Oh, okay, but we should be, this won't work.
So a hint here would be, I mean, your one pointer could catch the
Yes, yeah,
element and one
got,
pointer could catch the indexes.
got it.
And you go on updating your indexes when you find a non-zero element.
0.
Yeah, but your index is already -1, right? For the first iteration.
Yes, so we can give index the value of 0. It would be mapped to the first 0 in our list. And like, let's say if we encounter a non-zero element, so and if our index is not -1, then we can index is not -1, then we can replace p of index 5 with p of 5. So in this case, 1 would be replaced here, and we'll be having 0 here, and encounter for 0.
Okay, Nishit, no issue. We will just move to the next question as we have like 10 minutes left. So
Yeah.
we move on. I'll just paste the answer here, ideal answer here, so that everyone can see. Can you paste this uh, to your, sorry, I did not paste. Just a minute. Yep. Can you paste this on the notepad? Okay, so basically what we are trying to do is we are trying to shift the non-zero elements to the left and the zero elements to the right.
Right, yeah.
So we are catching a non-zero index which starts with 0. You started right. I mean, the first approach that you started with, right? You started indices as 0, which was right. Then you basically loop over all the elements and you find out whatever is not zero. Basically, you do a nums of non-zero index. So the 0th index will be replaced by the specific element. And then you increase the non-zero index by 1. In that sense, it will go on like 0. And for every 0th index that is coming, it won't increase the non-zero index to 1, right? By 1, it won't increase. So for the second index, it would give out 1 and 2. Or after your non-zero elements are in place, what you need to do is run a loop from your last of the non-zero index that you have. Suppose
Oh,
your three
okay,
elements
okay,
are there to the length of nums and you fill 0 in it.
okay,
So
okay.
in that sense, you will replace.
So in this case, it would be replaced by 1.
Yes,
This 0 would be replaced by 3
12,
and 12. And
then
in the
the
last
rest
loop, all these 3 would be replaced by 0.
by 0. Yes.
Okay, okay, got it.
Okay, okay. No issue. Let's move on quickly to the next question. Hmm. Okay. Let's see if we can build this. Okay, can you paste the question and the example on the notepad? This is also, you need to do it in the same array itself. Or you can try doing it using another array if that is easier. And then if we have time, we can optimize it.
Sure. You're given an array names.
So you are
Okay.
given an array 3, 1, 2, 5, 3. Suppose, so all the inclusive elements from 1 to 5 is there.
Okay.
What you need to find out, what element is repeating itself. So suppose 3 is the duplicate here, that comes first. So your output would be a list of duplicate comma missing. And what is missing between 1 to 5? So 4 is missing, right?
Okay, okay.
Yeah, that's the question.
So we just like there would be only one number which would be extra,
Yeah,
which
suppose
would have.
no, like suppose it's a 1 to 10. Like this is one of the examples. It
Mhm.
it should work with any use case as such, right?
Yes, yes.
Suppose your input is 1 to 10, and
Mhm.
out of that, 2, 5, 6 might be duplicating itself. So you can pass on like 2, 5, 8 first, and then comma, suppose 9 is missing, then you can pass on 9. So like that.
Can you paste this example too, if it's
Sure,
possible?
sure. Suppose, let me paste it. Suppose your input is suppose 2 numbers are missing. So suppose this is your input, your
But
out.
the question says there is exactly one integer that appears twice in nums and one integer that is missing from nums. So that I got.
Yeah, I mean, in this example, it is. I mean, here there is exactly one integer that is 3, 3.
Mhm.
Suppose you have two integers. I'm saying, I mean, just to kind of add a layer onto it, onto the question. Suppose you have two integers. Suppose 6 and 7. These are two integers that are repeating itself. You can pass a list to that. So your output will look basically a list in list, right? There would be two lists. So it could say 6, 7 are duplicating and 8 and 9 are missing. So this could be the output. You can copy the input and output here. I'll just clarify that. Okay, suppose it's a number from 1 to 10. Okay, here you see 6 and 7 are duplicating. So in the first place, so in the master list, the first I of 0 would be 6, 7, which will have J0 and J1. And then in the next I of 1, you will have the missing element, which will be again J0 and J1. So 8 and 9 are missing and 6 and 7 are missing. So again, if this is little bit difficult layer for you, you can go forward and solve the first layer first. Then we can look towards this.
Sure, sure. So in this case, if only one number is being repeated and one number is missing, then we can just take in XOR of the whole array.
Hmm.
So in this case, the XOR would be, and also, oh, so let's say the length of it is 5. So starting with 0. So here we'll get put as 1. Uh, so at this step, X would be holding XOR of 3 and 4. Because 4 is missing, 4 is being taken, and 3 is missing. Yeah.
So,
So
so before you go through this approach, can you also explain everyone like how does XOR operator works? I think that would like what is like the operation behind XOR operator? Like suppose it's a similar character like X XOR X, what would it give? And X XOR X not, what would it give?
I started with x0. So
Mm.
any number XOR to 0, it would be resulting in the same number. So
Okay.
if we XOR, like let's say in this array, if we are taking XOR of 3 and 3, it would be resulting 0. So it would like we can get which number is has been duplicated. So like similar in this case, if we XOR 6 and then 7 and like total XOR for this array would also be 0.
Right.
So for this array, we are taking XOR from all the elements from 1 to n, then taking XOR uh, on this array or list. So the resulting would be XOR of 3 and 4. Now we can uh,
So in your line number 59 and 60, so the syntax that you have written for I in range of 1 to n plus 1.
oh, mhm.
So in the last index, I think it would go out in a out of index error because it would go to search for a n plus 1 index.
It is an index and not the array of index.
Sorry.
I'm not passing a of I. I'm just passing the index. Like it is numbers from 1 to 5. I'm not passing a of I. If I would be passing a of I, then it would be gone out of index. Here
Okay.
I ranges from 1 to 5. So we can just take
Okay.
XOR for that. Then I'm just missing one point. We'll be getting sort of 3 and 4. Just missed one point here. Like we should be checking if the least significant bit is hit or not.
Least significant bit, did not get you.
Just a second. Yes. 4 is 0. In this case, XOR would be 0. Sorry, 101. Oh, okay. Now I got it. Here we can do is what is equal to x x of So what I did here is like I got the least significant bit, which would be 1. So our answer, like the XOR would be having either like XOR of 3 and 4. So either one of them will having this bit set and the other would be having this bit unset. So what I can do is again take XOR for
No worries, Nishit. I mean, you can try this at home later. Yeah, I think I'm done with my questions. Uh, we can end the interview right now.
sure.
Cool, cool. Anything else you have to ask?
No.
Okay.
Thank you.